Welcome to a new session of the differential equation. In this session, we discuss about reducible to separable form of a differential equation, which is what is called the homogeneous differential equation. Suppose sometimes some differential equation of the form dy by dx is equal to g of y by x, that is dy by dx equal to a function in y by x. Such kind of the differential equations are called homogeneous differential equations. This kind of differential equations are called homogeneous differential equation. Okay, to solve this kind of differential equation, we make this differential equation into separable form and then we will solve it. So, we put u is equal to y by x, that is y is equal to ux. So, we will differentiate. We have to find the value of dy by dx in new terms, that is why we find dy by dx. So, dy by dx is equal to therefore dy by dx is equal to dy by dx is equal to derivative of u and x. So, we consider u as a first function and v as a second function. So, we consider u as first function and x as the second function. Okay. So, we differentiate dy by dx is equal to first function u into derivative of x, that is 1 plus u dash, that is du by dx, derivative of first function into the second function x is there. So, we will have dy by dx is equal to u plus x into du by dx is there. So, we found a substitution for dy by dx, that is a substitution for dy by dx is u plus x into du by dx. So, we come back to equation number 1. In equation number 1, we have dy by dx is here in left hand side and g of y by x in right hand side. So, we apply in equation number 1. So, in applying 1, so we will have dy by dx equal to u plus x into du by dx, u plus x into du by dx is equal to, that is dy by dx is equal to, see here we have dy by dx equal to g of y by x. We gave a substitution for u y by x as u. So, we replace this as g of u. So, we have this is equal to x u plus x into du by dx is equal to g of u. See, we take all terms of u into right hand side, therefore, we will have we take u to here. So, plus u, while coming to right hand side it will be minus u, therefore, we will have see x into du divided by dx is equal to g of u minus u, g of u minus u is there. See, here we have this is equal to here we have x into du by dx is equal to g of u minus u is there. See, we have we take this is g of u minus u to here and we took dx into numerator and x into its denominator. So, we will have du divided by the value g of u minus u is there. So, the g of u minus u is there in denominator, which is equal to we take dx into numerator and this x into denominator. Therefore, we will have dx by x. See, what happened here? It is that we separated. We redefined as y by x as u. So, now we have equation, that is equation in u and x is there. We separated in that variables. In right hand side we have the terms of u only is there. In left hand side we have the terms of u only is there, and in right hand side we have the terms of x only is there. Now, we are okay, we can integrate. While integrating both sides, we will get solution in u and x. So, we will have solution in u and x. So, actually we applied as we substituted as u as y by x. So, after getting the solution, a general solution in u and x, we just replace, then we replace u by y by x. So, we then replace u by y by x. So, after replacing u by y by x, we will have a general solution in x and y. That is the general solution of the differential equation 1. That differential equation 1 is the homogeneous linear differential equation. See, this is the method to solve a homogeneous linear differential equation. We just substitute u as y by x, and then we find the value of dy by dx. Then we will substitute in equation number 1, and after substituting the equation number 1, we will have an equation in u and x only, and we can separate the variables. While integrating that separated form, we will have the general solution in u and x. So, after getting the general solution in u and x, we just replace u by y by x, then we will have a general solution. So, we can just move to some examples that will be more clear. This one, see example 1, solve the differential equation, 2xy y dash minus y square plus x square is equal to 0. I just put it as equation number 1. 2xy y dash minus y square plus x square is equal to 0 is the differential equation. So, while seeing the differential equation, we do not know the this is we just only understand it is that this is a first order differential equation. So, our thought is that how we will solve this differential equation. So, while seeing, we are unable to separate the variables. So, next our thought it is that have we able to make it as a homogeneous linear differential equation. So, I just divide 1 with a x square. See what will happen, 2x divided by, we divide all terms of equation 1 with x square. So, we will have 2xy y dash divided by x square is there, and minus y square divided by x square is there, and plus x square divided by x square is there. In opposite side, we will have this is equal to 0. See what will happen, it is here, this is we just divide 2x, we have 1 x is here, 1 x is in denominator, we can cancel. Therefore, we will have 2 into y by x into y dash minus y by x whole square, y square by x square, we can change this as y by x whole square is there, and finally, we have x square by x square is equal to 1. So, after all, h is equal to 0. See here in left hand side, while seeing the left hand side, which is a expression in y by x is there. So, we are able to change the equation as the equation in dy by dx is equal to is an expression in y by x. See, I just like to put this as equation number 2. See, from the equation number 2, I would like to take this is to here in RHS. So, while taking minus y by x whole square to there, we will have plus y by x is there, and plus 1 is minus 1 is there. So, see, we have this is equal to, see here 2 into y by x into y dash is there, 2 into y by x into y dash is there, 2 into y by x into y dash is there, which is equal to, see, we will have, we are taking y by x whole square is to there. Therefore, minus y by x whole square is equal to plus y by x whole square, and there is plus 1 is there. While taking plus 1 to opposite side in RHS, we will have minus 1 is there. Therefore, we will have minus 1 is there. See, here we have 2 into y by x into y dash. See, 2 into y by x into y dash, 2 into y by x into y dash is here. So, therefore, we will have y dash is equal to y by x whole square minus 1 divided by 2 into y by x is here. Okay. From here, this is C, here we have y dash is equal to some expression in y by x. Therefore, we can say this is the g of y dash is equal to g of y by x. So that we can say that this is a homogeneous, differential equation, first order differential equation. So, now we found this is a homogeneous differential equation. So, that is why we are happy we found that the given differential equation is homogeneous. Okay, fine. So, that is why we are able to solve this differential equation by using by putting y by x is equal to u. See, we can take we just put here we have this is equation number 2 is here. In this equation number 2, I just put y by x is equal to u. So, put y by x is equal to u in equation 2. Okay. So, we have y is equal to ux is there. So, we can differentiate, we have y dash is equal to u into derivative of x is 1 plus u dash derivative of first function into x is there, u dash into x is there. So, okay, fine. Now, y dash is equal to u plus u dash into x is there. So, we can come back to equation number 2, 2 into y by x is u. We have substitution for y dash is there, y by x is u. So, the equation 2 becomes as, see, in equation 2 into y by x into y dash. Therefore, 2 into u into y dash is there, that is this is equal to u plus u dash x is there. Fine. Again we can come back to equation number 2, this term is over, minus y by x whole square plus 1, y by x is u, minus u square plus 1, minus u square plus 1 is equal to 0. Fine. From here we have this is implies this is 2u into u, that is equal to 2u square, 2u into u dash x, that is equal to, we can say that 2u x u dash, okay, minus u square plus 1 is equal to 0. Fine. From here we have this is equal to 2u square minus u square is there. Therefore, from here we can say that this implies 2u square minus u square is u square plus 1 plus 2u x u dash is equal to 0 is equal to 0. Fine. From here we have to separate these variables. So, I just take this is to here, I would like to take this u square plus 1 to here. Therefore, while taking plus u square plus 1 to RHS, that will be minus u square plus 1. Therefore, we will have this is equal to 2u x u dash is equal to minus of u square plus 1. Okay. Fine. Now, from here we have 2u x u dash is du by dx is equal to minus of u square plus 1 is here. I would like to take this u square plus 1 into denominator, this dx into numerator, this x into this denominator. Okay, fine. Therefore, we will have this is equal to 2u du divided by, well, we can take this u square plus 1 to in LHS. So, while taking that is into LHS, that will be in denominator. So, 2u divided by u square plus 1 du. In opposite side, we have this is equal to dx divided by x is here. Now, we separated the variable. Now, we are happy we separated the variable. Now, we can integrate. So, integrating both sides. We can integrate both sides of this equation. So, while integrating both sides, we will have integral of 2u divided by u square plus 1 du is equal to integral of dx by x is there. Say put u square plus 1 as v. We just put v is equal to u square plus 1. What will happen? dv is equal to dv is equal to 2u du is there. So, we have integral of 2u divided by u square plus 1 du is equal to, we can replace this as integral of 2u du as dv. Therefore, this is equal to integral of dv divided by the u square plus 1, we substituted u square plus 1 as v. Therefore, this is equal to v. So, integral of dv by v, that is equal to, this is equal to log mod v. So, we can just replace v by u square plus 1. So, therefore, this is equal to log mod u square plus 1 is there. So, it is fine. Derivative logarithm of modulus of the denominator, because the derivative of the denominator is 2u, that is there in numerator. That is why logarithm of the denominator is the integral value. Now, fine, we found that this is equal to integral of 2u divided by u square plus 1 du as log of u square plus 1. So, okay, fine. Therefore, we can say that this is equal to integral of 2u du divided by u square plus 1 is equal to integral of dx by x is there. Therefore, we will have, this implies a log of u square plus 1 is equal to log x plus log c is there. The constant of integration, just type it as log c. See, we have, this is equal to log of u square plus 1 is equal to log x plus log c, that is equal to log cx. We can take the exponential function on both sides. Therefore, we will have, while taking the exponential function, we will have, this is equal to u square plus 1 is equal to cx is here. Now, we got the general solution. This is the solution in u and x is there. So, we put, we replace, we put u as y by x and y is equal to ux. So, we just replace u by y by x. See, just we replace u by y by x, we just replace u by y by x. So, this equation, I would like to put this as the equation number 3. The equation number 3 becomes, as, the equation number 3 becomes as, see, u square plus 1 is there. So, we replace u by y by x. So, y by x whole square plus 1 is equal to some cx is there. Okay, y by x whole square plus 1 is equal to some cx is there. See, so we can say this is equal to y square plus, I just put here x square LCM as, so x square in denominator we have x square, that is equal to some cx. Say, we can just take this is to here, this is equal to y square plus x square is equal to some cx cube. This is the general solution of the given differential equation. This is the general solution of the given differential equation. Now, if we need, we can just take this as the y square. This also can be written as y square is equal to cx cube minus x square is also y square is equal to. This is also a part of a general solution. Either we can write in this mode or we can write in this mode, no problem. In both cases, we can consider this as the general solution. So, this is the general solution of the given differential equation. See, my dear students, from where we start, it is that we have the differential equation 2xy dash minus y square plus x square equal to 0. We do not know whether it is homogeneous or separable, but we divided by x square. After dividing by x square, we just evaluated that equation. From that evaluation, we understood it is that the given differential equation is homogeneous. Now find, because that is homogeneous, we can put y is equal to some ux, or u is equal to y by x. So from the we found what the y dash, and we substituted in equation number 2. From there we found the general solution of the differential equation, while converting that equation into separable form. So we separated the equation into in variables u and x. After integrating this, we will have the general solution for that differential equation, and after getting the general solution in u, we just replaced u by y by x. So we got general solution in y and x. Now see, my dear students, we can do one more questions in example 2. Example 2, say solve the differential equation. Solve the differential equation x cos y by x, x cos y by x, into dy by dx, into dy by dx is equal to x cos y by x into dy by dx is equal to y cos y by x plus x. y cos y by x, y cos y by x plus x, y cos y by x plus x. Okay. So we just put that given differential equation as equation number 1. While seeing the differential equation, we just check whether the differential equation is homogeneous or not. See, here we have in left hand side, we have x cos y by x into dy by dx is equal to y cos y by x plus x. While seeing, we just feel that it is that the differential equation may be homogeneous. We have to check whether it is homogeneous, and we have to assure that is homogeneous. So I would like to rewrite equation number 1 as dy by dx is equal to y cos y by x plus x divided by x cos y by x. See, we have cos y by x is there in numerator and denominator, that is cos y by x is there. So we smell it is homogeneous. Now I would like to take x from the denominator. To make it, we have here some single y is there. In denominator we have one epsilon is there. So have to change that is into y by x. For that I would like to take this as, convert this as by taking x on outside. Therefore we will have, while taking x outside, here we have y by x cos y by x is there, and plus 1 is here, divided by, we have 1 x is here, cos y by x. Okay, fine. We can cancel it is as x and x we can cancel. Now finally we will have dy by dx is equal to dy by dx is equal to, see, y by x cos y by x plus 1 is there in numerator, y by x cos y by x plus 1 is there in denominator, in numerator, and we have cos y by x is there in denominator, just cos y by x there in denominator. See, we found and we converted into an equation number 2. While seeing equation number 2, we understood it is that the equation is dy by dx equal to some expression in y by x. Therefore this is of the form some dy by dx is equal to g of y by x. Now find, this is the form of the homogeneous, so that we can say that the given differential equation is homogeneous. The given differential equation is homogeneous first order differential equation. So, this is homogeneous first order differential equation. Okay, fine. As because that is homogeneous first order differential equation, we can put u as y by x. So, we just put u is equal to y by x. Therefore, y is equal to ux is there. So, we have dy by dx. dy by dx is equal to first function u, this is first function is, here we have first function is u and second function is x is there. So, first function we have u is there. So, u into derivative of x is 1. So, u plus. For derivative of first function, that is u dash, that is we can write this is equal to du by dx plus the second function, that is x is there. So, we can put in equation number 2. So, we just put in equation number 2. So, while put in 2, so we have dy by dx is equal to, instead of dy by dx we can write this as this is equal to u plus x into du by dx, sorry du by dx is equal to say y by x cos y by x plus 1. So, y by x into cos y by x is u cos u plus 1 divided by, finally we have cos y by x is there. So, cos y by x, that is equal to cos u is equal to cos u is there. Now, we can take u to on opposite side, therefore, this is equal to, we can take some minus u is there. So, we have see just we have x into du by dx, x into du by dx is equal to x into du by dx u cos u plus 1 divided by cos u, u cos u plus 1 divided by cos u, we take u to here, therefore, minus u is there. Therefore, we will have this is equal to some minus u we put here. Okay, fine. X into du divided by dx is equal to u cos u plus 1 and we take the cos u to here, therefore, we will have minus u cos u is there. We just take to this is here. So, we will have some minus u cos u plus 1 minus u cos u divided by cos u is there. Okay, fine. Here we have u cos u minus u cos u is there. Therefore, finally, we will have x into du divided by dx is equal to 1 by cos u, 1 by cos u. So, we can take the terms of u to here, terms of x to here. Therefore, we will have finally, we will have this is equal to see du cos u du is there. Therefore, we will have cos u du is equal to cos u du is equal to, finally, we have dx divided by x is there. Therefore, this is equal to some dx by x is there. Okay, now we separated the variables. So, we can integrating both sides. So, while integrating, integral of cos u du is equal to integral of dx by x is there. Okay, integral of cos u, that is equal to sin u is equal to integral of cos x is log x plus c is there. So, we can replace u by y by x, replace u by y by x. Therefore, we have sin of y by x is equal to sin of y by x is equal to some log x plus c. Okay, fine. Up to here only it is possible. Now, if we need, we can take y by x is equal to sin inverse of log x plus p, no problem. This is enough. So, this is the general solution of the given differential equation. So, while seeing in literature, we can find many questions that can be converted into homogeneous first order differential equation, and also that differential equation can separate, can be changed into variable separable method, and by using the variable separable method we can solve the differential equations. I just give you some assignments. The first one is solve x into x minus y, x into x minus y dy by dx plus y square is equal to 0. The second one, solve dy by dx is equal to x square plus 3y square, divided by 3x square plus y square, Okay. While searching in the literature of the differential equation, we are able to find many questions of the homogeneous linear differential equation, or you try to solve such kind of the differential equation. Thank you for watching these videos. Continue watching. Thank you very much.